A 50 caliber sniper round doesn't just kill, it can blow off limbs, turn organs into particles, or even decapitate a person from over a mile away. That's the terrifying power packed into a single bullet. But how does something so small unleash that kind of destruction? The answer lies inside bullet factories, and it's more mind-blowing than you would ever expect. Bullets weren't always the modern, sleek projectiles that we have today. They began as simple lead balls, which were unreliable, heavy, and largely ineffective. These round balls, along with gunpowder, had to be manually stuffed into muskets in early America in the 1400s and 1500s. Accuracy was mostly dependent on chance, and each reload was slow. Significant changes occurred in the 1800s. The mini-ball revolutionized the game. It spun through barrels with unique grooves, increasing the accuracy and the range of shots. This was enormous. This innovation raised the death toll during the Civil War because soldiers could actually, hit what they were aiming at. Then followed the metallic cartridge, which was an even greater advance. This clever design integrated the igniting system, gunpowder, and bullet into a single tidy package. Now, rather than mess about with loose powder, you could reload and fire rapidly. Each of these bullets begins its life at the center of a factory where precision and sheer brute force both reign. First thing, choose some proper materials. Lead and copper are the two first heavy knocks. The heart of the bullet or the muscle is lead. It impacts hard, it's heavy, and it's dense. Perfect for deep penetration and crushing. But it requires the mate. The shiny outer shell is copper. Similar to armor, it surrounds the lead, reducing friction, raising velocity, and keeping the barrel clean. Massive lead ingots are melted into a molten power of destruction in thundering industrial furnaces. It's then cleaned and free of flaws to ensure flawless operation. Copper, on the other hand, is available as flat sheets or heavy rolls. Every detail counts when creating something this precise, which is why it's inspected, tested, and prepared. This is the intersection of ballistic science and industrial might. However, the true magic is just getting started. Now that the basic elements are ready, the power needs to be shaped. This phase is known as swagging, a method that produces accuracy in addition to shaping metal. Pieces of lead, referred to as slugs, are cut into precise sections. These aren't merely scraps, they're the beginnings of something incredibly precise. Every slug is inserted into a swagging die, an impeccably designed mold. The next piece of armor that gives the bullet its durability and competitive edge is the copper jacket. To initiate the process, thin copper sheets are initially cut into small precise circles called blanks. These gaps provide the framework, but they'll be modified shortly. The copper blanks are passed into progressively smaller dies via a sequence of shaping and drawing methods. The blank is compressed, stretched, and bent into a long, thin tube with each pass. This will eventually become the bullet's jacket. Why is this process so vital? It's because the thickness and consistency of the jacket determine the bullet's ability to absorb the heat and pressure of firing, as well as affect its accuracy and capacity for expansion upon hitting its target. The last copper jacket must fit around the lead core with precision perfection, forming an intimate bond between the two pieces. This snug fit enables the bullet to perform under pressure, propelling power each time it is fired. Now arrives the thrilling phase, assembling everything to create the bullet. The produced lead core is carefully inserted into the copper case by workers. This must be extremely accurate because if the core is not fitted perfectly, the bullet will not travel straight or use up all of its energy. It's like making sure a piece of the puzzle fits precisely. These two halves are then firmly pressed together using specialized machinery. They also add final touches during this process, including cutting tiny rings around the jacket or shaping the tip. More than just a cosmetic element, these rings, also known as cannulars, help keep the bullet safe inside its casing until it's fired. They increase accuracy and ensure that the bullet will fire with maximum force by holding the cartridge firmly in place. The bullet's performance is greatly impacted by this minor detail. Heat treatment is where the transformation of the bullet takes place. In this process, the bullet is heated and slowly cooled to make the metal more ductile so that it doesn't crack under pressure. This process also removes internal stresses so that the bullet functions reliably when fired, shot after shot. In order for the bullet to strike the same measures needed, they go through dies. That way, the bullet will sit exactly in the barrel of the gun so it can interact with the rifling to provide increased accuracy and performance. The bullets may also carry unique markings or colored tips to help identify them. These markings are important in the identification of ammunition by type or use, allowing shooters to easily select the appropriate bullet when necessary. Each bullet goes through a thorough inspection process to ensure top quality standards. Specialists use precise measuring tools like calipers and micrometers to check the bullet's exact diameter, length, and weight, making sure every single round falls within the required specifications. After measurements come the performance tests. During ballistic testing, manufacturers fire the bullets in controlled settings to truly see what they can do. Experts carefully analyze how fast they travel, the path they take through the air, and how closely they cluster when hitting targets. Certain bullets are tested to see how effectively they expand and pierce different materials in order to ascertain their actual potential. Additionally, the hardness of the ballistic bullets is evaluated utilizing specialized testing apparatus. According to the testing, the bullet's hardness is exactly right, not too soft to result in undesired deformation, but not too hard to stop expansion upon contact. This guarantees that every bullet will behave precisely as intended when it's needed most. After completing all testing and examinations, the bullets are sorted meticulously and packaged. When reloading is considered, bullets are usually in bulk packaging as they can be reused. A primer, a case, and gunpowder are all combined to create a totally functioning cartridge to provide total ammunition. They're packed in lots of 20, 50, or 100 rounds, depending on the quantity. The bullet type, caliber, and lot number are indicated on the packet, allowing for complete traceability for quality assurance and safety. The process of creating a bullet is an engineering wonder, involving everything from molten metal to pinpoint precision. Every step, shaping, assembling, proofing, is taken with great caution, for when a bullet has been fired from the barrel, there's no room for error. The next time you see a bullet, remember the complex process it went through from raw material to high-performance round.